Okay. We're given the equation 7x plus 4 equals 5 over x plus 5. And I should have noticed which problem this is, but this is problem, no, it's not 5, it's number 6. Problem 5, incidentally, is just another quadratic equation, and it's in the form where it's already equal to 0, and we learned how to do that last time, but I wanted to reinforce it with another problem. Okay, so anyhow, this equation, it's not immediately clear what kind of equation this is. Okay, but I'm claiming this is going to turn out to be a quadratic equation. Now, what do we do when we have an equation like this? We notice it has a denominator. Denominators are a pain in the neck. If you want to add things that have denominators, you're going to usually have to find common denominators and do a bunch of stuff, and we did some of that last time. You know how to do that, but it's not necessary to do that when you have an equation. Okay? When you have an equation, you can get rid of your denominators just by multiplying by a common denominator. Okay? Any common denominator. You can multiply by the product of all the denominators, that would do it. You can be a little more selective. We're not going to worry too much about that now. I just want to illustrate the whole concept of clearing the denominator. So I say you clear the denominators. Now, you know, that statement could have been interpreted without the word "the" in there as the denominators are clear. That's not what it says. Clear the denominators. To do that, we multiply by a common denominator. Any common denominator will do it, but you usually want to use the least common denominator because it's simpler. You get a simpler form of the equation. And boy, somebody forgot to put a set of parentheses there. Okay, I guess that was me, wasn't it? Okay, so the denominator is x plus 5, so we multiply both sides by the common denominator. X plus 5 times this side, x plus 5 times this side. Well, the distributive law here, and you need to write out the details of that, give you x squared plus 39x plus 20. If I did it right, check me. Okay? Then x plus 5 times 5 over x plus 5. I worked this out in some detail. That's the same as x plus 5 over 1 times 5 over x plus 5, just so you can see clearly that we have a numerator and a denominator in each fraction, so we can multiply numerators and multiply denominators, and clearly we get this, the product of the numerators over the product of the denominators. Now, I rearrange this just by reversing the order of the 1 and the x plus 5, and when I do that, and it's not absolutely necessary to do that, but this shows clearly that I could write this product back as a product of two fractions, the first fraction being x plus 5 over x plus 5, the second being 5 over 1. So I've converted this form to this form. Now, of course, x plus 5 over x plus 5 is 1, so that's 1 times 5 over 1. And of course, 5 over 1 is 5, so that's 1 times 5, or 5. So I end up with 5, which of course is just the numerator here. Remember, I don't acknowledge the existence of cancellation.